Hey guys, happy Monday. Hopefully you guys had a nice restful weekend. So of course I'm not here today, but I still want you guys to set up notes exactly how you guys normally do. And do the warm-up here. We have essential standard number 3, solve the system of linear equations. So again, pause the video, set up your notes, and then I'll go through the process in a second. Alright, so here we have a system. Now, of course, we do want to eliminate, it could be either x's or y's. Here I'm going to go with the x's. Now, again, if this is a positive 3x, this guy up here has to be a negative 3. So I need to multiply the entire one by negative 3. So if those x's cancel out. Now, again, make sure you distribute to the x here, which gives us negative 3x. Distribute to that negative y, which gives us positive 3y. Distribute to that 8, which gives us negative 24. Now again, the bottom one, guys, I'm going to keep that one the same. Just stack it up nicely. 3x plus 2y is equal to negative 1. Now, of course, the whole reason I did that was so that, well, 3x's minus 3x's, that's going to cancel out. 3y plus 2y, that's obviously 5y, is equal to, now be careful here, you owe me 24, and then you owe me another $1. That means negative 25. Now, one step here, I have to divide both sides by 5, and I get y is equal to negative 5. Now, of course, that's just half my answer. I need to figure out what x is. Now, I'm going to use the first equation. We have x minus y is equal to 8. Now, of course, I figured out what y was. Y is negative 5, but you got to be careful when you substitute because this is really x minus from the original problem, and y is a negative 5. So I'll put this in parentheses. Well, what ends up happening here, this double negative is actually a positive. We really have x plus 5 is equal to 8. Well, how do we get rid of that plus 5? I say minus 5. Minus 5, I get x is equal to 3. So that is our solution right there. X is 3, y is negative 5. Now, of course, we write it as 3, comma, negative 5 as an ordered pair. All right, guys. So today's lesson is, well, what's going to be on the performance task? The performance task is this Wednesday. And of course, I'm not there tomorrow. You guys are going to be working on a class activity together and making the performance task. So again, I still wanted to review with you guys through this video of what to expect. What are the skills that I need, right? So again, I need you guys to take this seriously, watch the whole thing through. If you have any questions, make sure you jot them down so you can ask me tomorrow. All right, so let's jump right into it. So what's our situation? You're going to be given this floor plan, basically, you have over here on the right-hand side. You know, you have your living room, your kitchen, you have the bathroom, the closet, the bedroom. And again, we have these dimensions up here. So again, we'll use the following floor plan to answer questions regarding length, perimeter, and area. So those things are coming back, right? Perimeter and area. Now, don't forget, we have to make sure we know how to read this compass here. Now, again, pointing upwards here, north, east, south, west. All right, so we're going to use this little floor plan to help us answer several questions. Essentially, that's what your performance test is going to be like. No need to copy this down. It'll show up constantly. All right, let's move on to the next slide here. So the very first question that they give us is, hey, what is the length of the north side? Now, again, it's important that I know how to read this. Well, if I see my compass here, north, right? North is up here, east, south is down below, and west is to the left. But they want the length of the north side. Now, they don't just want a little piece. They want the entire length. So I need this segment, I need this segment, and I need this segment. I need all three segments to find the total length of the north side. So what do I have to do with that is I have to add all three pieces together. Essentially what I'm left with is, hey, I have to add 2x plus 3 plus an x plus an x minus 1. If I add all three pieces, that's going to give me the entire length of the north side. Okay, so what do I do here? Well, this becomes just like adding polynomials. Well, how do I get rid of all those parentheses? Let's go ahead and distribute those ones, right? That comes down as 2x plus 3. That comes down as simply just positive x or positive 1x. I'll throw in the 1. Same thing here. Throw in the 1. Distribute that one. That is going to be 1x. And distribute that one. It gives you negative 1. So I have this very, very large polynomial. Now, again, we do that just to get rid of our parentheses. Now, I always like to write this in standard form. So let's start off with the 2x. Cross that off. Move on to the positive 1x here. Move on to 8. We have another positive 1x. we have the positive 3, and we have the negative 1. Cool, so it's in standard form, which is nice because all I can do now is combine my like terms. I have 2x's plus 1x's plus 1x's, which is going to give me for a length of 4x here. Now my other set of like terms are the constants here, 3 minus 1, which is going to be a positive 2. So what is the length of the north side? The length of the north side is 4x plus 2. So again, if they had asked us for the length of the east side, I'd be adding everything over here on the right hand side. If they wanted the length of the south side, of course I have to add the bottom 2 pieces. Same thing for the west, I'd add these left 2 pieces. All right, let's move on to the next example here. Oh, before that, what is perimeter? So again, we have this before. You don't, there's no need to copy the slide down unless you forgot this stuff. But what is perimeter? Perimeter is the continuous line forming the boundary of a closed geometric figure. In other words, if you have a triangle, if you have a square, rectangle, whatever. So again, it's that line that goes on the outside. And how do we calculate perimeter? Well, you basically just add up all the sides. Okay, I would add up all 3 sides of this triangle, all 4 sides of the square, depending on the shape. Now, what are some uses? Why is this useful? Well, in the real world, if we ever want to put up fencing in order to plot some crops or to go around your home, again, you can't just go to the hardware store blank, not knowing anything. You need to know how much material you need for that fencing. So again, how does perimeter come up? Well, we need to figure out that total length. All right, so let's move on to an example that has perimeter. So this question here, you do want to do this. It says calculate the perimeter of the kitchen. Now I have this master floor plan down here, but I'm only looking for the kitchen. And again, I know perimeter. How do I find it? Well, I add up all sides. Well, how many sides does this kitchen have? I know it has 1 here, 2, 3, 4. So there's a total of 4 sides here. So in other words, I need to add up 4 sides here. Okay, that is going to give me my perimeter. Well, the nice thing is, hey, I have this. This is x minus 1. This is one side right here. So let me put x minus 1. Oh, sorry, excuse me, x minus 2. Here we have another side, which is 2x plus 3. Okay. Now, well, I know that this is a rectangle, so I know that, hey, the opposite side up here also has to be 2x plus 3. Well, let me add that one also, 2x plus 3. And similarly, if I go across this way, I know that this side is also going to be x minus 2. All right, there we go. I have all 4 sides. Now, of course, I don't want you guys to leave it like that. We do have to add up all these pieces. So let's start off by distributing these ones. Now, when you distribute those ones, now, of course, all this is really doing is getting rid of our parentheses. I know some of you guys like to do this in your head or just right there on the picture, combine like terms, which is cool. Go for it if you're okay with that. So again, here I get still x minus 2 plus 2x plus 3 plus 2x plus 3 plus x minus 2. Now I'm going to combine like terms and put this in standard form all at the same time. Here I have an x, I have a 2x, I have a 2x, and I have an x. Well, if I combine all of those together, x plus 2x is 3x's, 3x's plus 2x's is 5, 5 plus 1 more x gives us 6. So I have 6 x's. So far my perimeter is 6x. Now let's take a look at my constants. I have a negative 2, positive 3, positive 3, and a negative 2. So negative 2 plus 3, that's a positive 1. Positive 1 plus 3 is 4. 4 minus 2 is a positive 2. So again, what is my perimeter? I'm going to use P here for perimeter. Perimeter is equal to 6x plus 2. Again, that is the perimeter for the kitchen specifically. Now again, you would do the same thing if they asked it for the bathroom, the closet. You would add up all 4 sides of that room. Okay, now we talked about perimeter. Of course, we're going to talk about area. So same thing here, guys. If you need this, go ahead and copy it down. So what is area? Area is the square units that are contained within a certain figure. So in other words, it's the space inside. So again, if you have a rectangle here, it's all the little square blocks. How many square units are in there? So again, it's the space inside all that. All right. So how do we calculate it? Well, certain figures have their formulas. For squares and rectangles, it's simply you calculate it by multiplying the length times the width. Now, what are some uses? Well, if I want to figure out, hey, how much carpet do I need to put down on my floor, my new bedroom? Again, you need to know these numbers. So how do I calculate it? Well, if it's a square room or rectangle, I'd multiply length and width. Again, even in this room, how many desks can I fit inside? Well, I need to know what's the area, how much space do I have to work with. So let's move on to a problem that talks about area. So this one says, calculate the area, you do want to copy this down, area of the closet. Well, where is my closet? Closet is right over here. So again, in order to calculate area, I have to multiply my length times my width. Here's my length, x minus 1, times, what's my width? Also x minus 1. Okay, now I have two options. I can either use double distribution or I can use Punnett square. Again, most of you guys like double distribution, so here we go. We say, hey, x times x is going to give us x squared. X times -1 is -1x. -1 times x is -1x. -1 times -1 is a +1. And of course, we want to combine like terms. So x squared, this right here gives us -2x plus 1. So what is the area of this closet? Well, it's going to be x squared minus 2x plus 1. Okay, now we get into these types of problem, which is kind of a little bit interesting. So it says, what if I give you guys the area? What if the area of the rectangle below is 24 inches squared? What are possible lengths and widths? What's a possible length and what's a possible width? Well, remember, I got 24 inches squared from multiplying some length times some width, some length times some width. So what are possible options? Well, what things multiply to give me 24? Well, of course, I can say, hey, it's 24 and 1, so the length could be 24 inches, width could be 1. I could also say, hey, this could also be 12 times 2. Length could have been 12, width could have been 2. What else? Can I say 6 times 4? That's another option. So again, notice these are all pretty much all the possibilities. I can say, hey, this could be 12 inches here by 2 inches. And I found my length and my width. Now, length we typically associate with the longer side. Now, again, width is the shorter. But now what happens again? That's pretty basic. Again, we were working with polynomials here. So what happens now if I have something like this? What if the area was x squared minus 2x minus 24? You do want to copy this down. What if I want to find, hey, what's that length and what is that width? Well, I know this is a quadratic. I know this came from two binomials. So what I'm going to use is I'm going to use the Punnett square. Okay, I'm going to show you what that looks like in a quick second. So I'm going to set up my Punnett square. All right, so here's my Punnett square, guys. Now, again, I went through a few of them here. I set up my x squared, my minus 24. I know x and x gives us x squared. The secret combination, I'm going to go with this one right here. So I'm going to put -6 and +4. This means that this is -6x and this is a +4x. Now again, I want to double check 4x's minus 6x's. Yes, that does give me that -2x piece that I needed. So my two options here are x minus 6 and x plus 4. Now, which is length and which is the width though? Well, length, we typically associate with the longer one. Now, which of these is going to be longer? Well, would it be longer if I subtracted 6 from something or if I added 4 to that something? Well, if you add, you're going to make it much bigger. So again, my length should be the x plus 4 piece. My width should be the x minus 6. So again, in other words, how do you go backwards from a quadratic? Well, you factor it using the Punnett square here. You break it apart. So guys, what I'm going to do is I'll pause the video right here. I'm going to do a part 2. So make sure you watch and follow along. Actually, if you want to pause it right here, I want you to try this out. I give you that the area is 3x squared minus 20x minus 7. I want you to give me that length and what is that width. All right, guys. So try it out and then move on to part 2.